Hello everyone, welcome to this video. In this video, we shall see question from December 2019 consisting of 4.75 marks. The question says, if fx belonging to zx be any monic polynomial with degree n, then which of the following are true? So we need to tell among these four what is the correct option, right? So firstly, there's asking fx is irreducible in zx, then it is also irreducible in qx. Secondly, fx is irreducible in qx, then it is also irreducible in zx, right? Third option says fx is reducible in zx, then it has a real root, and conversely, if fx has a real root, then it is reducible in zx. So let us first see about these two, right? So there's a Gauss lemma for irreducibility. It says that any non-constant polynomial in Zx, right, is irreducible in Zx if and only if it is both irreducible in Qx and it is primitive. What do you mean by primitive? That means the GCD of coefficients of that polynomial that is equal to 1. So now you have been given the polynomial to be monic polynomial, right? That means the leading coefficient is equal to 1. Therefore, the GCD would obviously 1, right? So this condition is true for as in we are given a monic polynomial. Therefore, we have the if and only if condition, right? So in the first case, they are saying fx is irreducible in zx. It implies it is irreducible in qx by this Gauss lemma, right? Therefore, this option is correct. Moreover, second option, they are saying fx is irreducible in qx. Moreover, we have this property of primitiveness. Therefore, it is also irreducible in zx according to this Gauss lemma. Therefore, option A and B, they are correct, right? Now, let us move on to option number C. So they are saying if fx is any polynomial which is reducible in this ring of integers, right, we need to check whether it has a real root always, and this is the case always, right? So how do one start looking for such thing? Can you remember any kind of result for this? If not, to check any such criteria, what we do, we go and look for some polynomial such that this first condition is satisfied but the second is not. If you are able to find one such polynomial, then you say this is incorrect, right? So can we have something like this? So fx is given to be reducible in zx. We are looking for that polynomial which does not have real root. So polynomial of this kind, this does not have a real root, because if you equate this to 0, you'll get x as plus minus iota, which belongs to the set of complex number and not to the set of reals, right? Therefore, this polynomial do not have real roots. And similarly, x square plus 2, this polynomial also do not have real roots, right? So if you multiply these two polynomials, so x square plus 1 into x square plus 2, you will be getting some polynomial of this kind, x raised to power 4 plus 3x square plus 2, right? Now this polynomial of 4th degree, this has reducible factors, this one, and the only roots for this polynomial are plus minus iota and plus minus square root 2 iota, right? So these are the roots of this, and which are complex roots and are not real roots. Therefore, we found one such polynomial. Therefore, we say that this option is incorrect because this is not true always. Similarly, for the last option, we are assuming a polynomial which has real roots, right? And we need to check whether always this polynomial is reducible in zx. So instead, what we do, we assume this thing and we look for that polynomial which cannot be reduced in ZX. If we are able to find one such example, one such polynomial, we can say that this thing is not true. Otherwise, we need to check it for the general case, right? So, do you have any example with you? Fx has a real root. That means you can take this to be x to be square root 5. This is also a real root, right? Being irrational number. And then you could square both sides. So you have something like this. Now this polynomial has real root, right? One root is square root 5 and one root is minus square root of 5. Therefore, first condition is satisfied. So this polynomial has real roots. Second thing, we are looking for a polynomial which is not reducible in ZX. Now, can you reduce this polynomial whose coefficients are present in the set of integers? I guess no, because you can only write this polynomial as x minus square root of 5 and x plus square root of 5, and whose here the coefficients are 1 minus square root of 5, 1 plus square root of 5. This factor and this factor, they do not belong to the set of integers. Therefore, we got one example polynomial f of x is equal to x square minus 5, which has a real root, right? But it cannot be reduced. It is not reducible in ZX, right? So this thing is not always true. Therefore, this option is also incorrect. So the only correct options for this question, they are option number A and option number B. Well, that is it for this video. Thank you for watching.